Welcome to The Explainer. Today, we're going to dive into a pretty wild concept for propulsion, one that comes from a manuscript that really challenges how we think about moving things.
So it all boils down to this one huge question. Can an object, all alone in the vacuum of space, actually move forward without, shooting something out behind it? I mean, all of our physics says no. That should be completely impossible. And it's all because of one very famous and supposedly unbreakable rule.
And that rule is, of course, the law of conservation of momentum. It's basically the foundation of all motion. It just says that a system's total momentum can't change unless an outside force gets involved. You push something, it pushes you right back. Simple as that.
But what if a system could act on itself to get moving? What if you could actually create forward motion just by rearranging its internal parts in a really, really clever way? Well, that's the paradox we're going to get into today. The author behind this whole idea, Michael Lewis, he proposes a system he calls closed-loop pulse propulsion, or CLPP for short. And his big claim is that it doesn't break the laws of physics at all. Instead, it uses them in this revolutionary three-step cycle to do what we thought was impossible. Okay, so how does this thing supposedly work? Let's break it down. It all starts with a very familiar action-reaction idea. The very first step is all about creating a separation. Just like the slide says, picture yourself in space, firing a shotgun. That blast pushes the bullet forward, right? But it also shoves you backward. You started as one system, and now you're two, moving apart with equal and opposite momentum. So in this CLPP setup, you've got an internal railgun that fires a heavy slug toward the front of the ship. This does the exact same thing. It creates a clear separation of momentum. The slug zips forward, and the ship itself gets pushed backward. That's our initial motion. Okay, now hold on, because this is where things get really, really clever. The next step is all about changing what kind of momentum that slug has, without messing with the ship at all. You see, the big secret to CLPP is about switching tracks. You take the slug's straight line motion, that's its linear momentum, and you convert it into spin, which is angular momentum. It's kind of like taking the energy of a bullet and storing it in a spinning top. So right before that slug can slam into the front of the ship, it gets snagged by a tether. This yanks it out of its straight path and whips it into a spin. And as that tether wraps around a center point, it gets shorter. And just like an ice skater pulling in their arms, that slug starts spinning incredibly fast. But okay, wait, what's the ship doing this whole time? Does it just stop? The author's whole point is, nope, because that spin is happening inside the ship, it's an internal action, so it doesn't affect the ship's overall movement. The ship just keeps on drifting backward from that initial recoil, completely unaware of the crazy spin-up happening inside. All right, on to the final step, the payoff. This is where all that stored-up spinning energy actually does something. And we're talking a huge amplification of energy here. That slug, it was fired from the railgun at just 20 miles per hour. But now, thanks to the physics of that spin, it's whipping around with a tangential speed equal to a whopping 140 miles per hour. Its energy has been multiplied big time. So in step 3, we flip the switch back, the tether system lets go of the slug, and boom. All that stored rotational energy is converted right back into straight-line motion, but now at this new, much, much higher speed. And this is the magic moment. Remember how the ship was slowly drifting backward at maybe 1 mile per hour? Well, now this super fast slug smacks into the front of the ship. The impact is way, way bigger than that initial pushback. As you can see right here on the chart, the result is a real net gain in forward velocity. Okay, so let's zoom out and look at the whole cycle, all 3 steps working together in this one elegant loop. It's this beautiful little loop. Step 1, thrust. You fire the slug, and the ship recoils backward. Step 2, spin. You convert that slug's motion into rotation, amplifying its energy. And step 3, thrust again. You release the high-speed slug, it smacks the front, and the whole system moves forward faster than it was moving backward. And here's the real kicker. This isn't just a one-and-done thing. You can repeat the cycle over and over again. Each pulse stacks more speed on top of the last, and you do it all without ever shooting a single puff of gas out the back. You're just recycling and amplifying momentum inside a closed box. So, if this actually works, just think about the implications for a second. It's not just a small change, it would completely rewrite the rules of propulsion as we know them. And the author, Michael Lewis, isn't just thinking about spaceships. He sees this transforming technology right here on Earth, from making electric cars insanely efficient to creating entirely new ways of generating power. Which leaves us with this really mind-bending question to chew on. Could the future of getting from point A to point B be found not by pushing against the world, but by just playing a smarter game with the physics inside the box? It's a fascinating thought, isn't it?